Good afternoon, class. We are looking at Chapter 4, Application of Derivatives, Section 4.4, Optimization Problems. And here's second part to finish off the problems here. We want to find two numbers whose difference is 18 and whose product is a minimum. So first, let's define the numbers as x and y. The objective is to have a product which is minimum. P represents the product, x times y. The difference is 18, so x minus y must be 18. That's the constraint. We solve for y, and we replace it here. So this moves this way, this moves this way. We have y equals x minus 18. And if we put it in here, now p, which is a function of x and y, becomes p of x, x times x minus 18, or x squared minus 18x. The domain is all real numbers because we want to minimize the product. 0, negative, all are acceptable. We take a derivative, 2x minus 18. When we set it equal to 0, the CP becomes x equals 9. We have one critical point. We have an open interval. So whether we do the first or second derivative test, local becomes absolute. We do the second derivative test because p double prime is simply positive 2. And positive means concave up. Looking like that means minimum occurs when x equals 9. So we can use this formula or this formula to find y, which is 9 minus 18 or negative 9. And if we had chosen to write y minus x equals 18, then x would be negative 9, y would be positive 9. The point is, there are two numbers. One is positive, one is negative 9. What is their minimum product is negative 81. Example 6, let us enclose a rectangular area of 288 square feet and then divide it into 3 equal size pen with parallel sides. What dimensions will minimize the material needed? First, let's look at the shape, define our variables. The sides are x and y. The objective is to minimize the material. We have x here, 1, 2, 3, 4x. We have y here, and we have 2 of them. So 4x plus 2y. That is what we want to minimize. We call it P. Perimeter is 4x plus 2y. What is the restriction? It's subject to the constraint. The area must be 288. So x times y. Area is x times y equals 288. Again, p is a function of two variables, namely x and y. So you're going to solve for y, making it 288 over x. And over here, this is fine. The y is replaced. So this is 4x. This is 2 times 288 or 576 divided by x, or 576 x to the power minus 1. We write it in this fashion because of the next step, which is differentiation. And x must be positive because x represents a dimension. Each side must be positive. In other words, we have the open interval of 0 to infinity. We are going to differentiate in order to get to critical points. 4x gives us 4. The second piece gives us the product of these two numbers, minus 576, x to the power of negative 2. And we are going to take this down, make it minus 576 over x squared. We're going to take a common denominator, which is x squared. So this becomes 4x squared minus 576 over x squared. To find critical points, we look at p prime equals 0. P prime does not exist. P prime does not exist. That means the denominator is 0, and 0 is not part of the domain. So just the numerator equal to 0. This means 4x squared is 576 divided by 4. That means x squared is 144. So x is plus minus square root of 144 or plus minus 12 feet. X has to be positive because it represents dimension. So only x equals 12 feet is acceptable. Let's check to see if it's going to be a local max or local mean according to the test. And then because it's the only critical point, one critical point in an open interval, then it becomes absolute. So we go with the second derivative test, and we are going to find p double prime. So from here, we are going to differentiate again. We get p double prime of x equals, this one is just 0. The product of minus 576 and negative 2 gives us positive 1152 x to the power of negative 3. We're going to write it as 1152 over x cubed. And the second derivative test says plug in the critical point and observe whether it's positive or negative. So when we plug in, you don't even have to evaluate this to know 1152, which is a positive number, over 12 cubed, which is a positive number, results in a positive value. If you work it out, it becomes 2/3, but you can check it out. So, but you don't have to. Notice that we just want the sign. Positive means concave up, which means the minimum occurs when x is 12 feet. Because it's the only critical point, it's an absolute minimum. So if x is 12, what is y? Use this one or use this one. 288 divided by 12 results in 24 feet. So the dimensions are x is 12 feet, y is 24 feet. And if they ask for what is the minimum material, 4 times 12 plus 2 times 24, resulting in 96 feet, if they ask you that. All right, we are going to move on to the next question. From a thin piece of cardboard, 8 by 8, 8 inch by 8 inch, square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield the box of maximum volume? What is the maximum volume? So we have an 8 by 8 piece of card. We're going to cut the corners, and we're going to cut identical corners so that this is x. So if this is x amount, because we don't know, then this is x amount, x, 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 all of them are x. So the middle part is 8 inch minus this x as well as minus this x, making the middle part as 8 minus 2x. 8 minus 2x. When we fold it up, it looks like a box. 8 minus 2x, 8 minus 2x, x. So the objective is to maximize the volume, which is the length times the width times the height, because And this is a rectangular solid. Subject to the length and the width are identical to 8 minus 2x, and the height is x. And now you can replace this with what you have here, results in the volume being x times 8 minus 2x quantity squared. Now, restriction on the domain. X must be between 0 and 4. Why is that? First and foremost, you're cutting something, so x can't be 0. Secondly, if you look at this one, if x is 0, the product is 0, the volume is 0. Secondly, x can't be 4. First of all, if you cut this into half, becomes 4 and 4, you won't have a box. Secondly, if 8 minus 2x equal to 0, x becomes 4. When x is 4, the product is 0 and there is no volume. The bottom line is, at x equals 0, we don't get a box. At x equals 4, we don't get a box. So it has to be in between. Can it be larger than 4? Of course not, because when you cut it in half, the maximum that you can cut is half of it, which results in no box, by the way. So x is between 0 and 4. This plays an important part. So here's your open interval of 0 to 4. Now we are going to work with algebra and simplify this. You're going to square this. You get 8 squared, which is 16, minus the product of these 2 times 2 minus 32x squared. This one you get 4x squared. And then when you multiply by x, you get 64x minus 32x squared plus 4x cubed. Put it in descending order, you get 4x cubed minus 32x squared plus 64x. Now, we do calculus. We differentiate. We get 12x squared minus 64x plus 60. Because we want to set this equal to 0, we are going to factor, and first and foremost, we factor the 4 out, because the numbers 12 and 64 or negative, doesn't matter, 4 is in common. And then because we want to factor this, and 3 is a prime number, everybody. So this part has to be x and 3x, because 3 is a prime number. What about 16? 16 is 1 times 16, 2 times 8, 4 times 4. Both of them have the same sign, because that's the meaning of plus. Both are negative or both are positive. Trial and error or any other method you can use, and the answer is, as you can see, if you look at the product of these two, minus 4x, the product of these two, minus 12x, they add up to negative 16x. So the middle term must be checked always when it comes to factoring. So what is x? If you set this one equal to 0, x is 4/3. If you set this one equal to 0, x is 4. Going back to this, obviously x can't be 4. So we are dealing with an open interval of 0 to 4 and one critical point. So whether it's a local max or mean, we don't know. We're going to check it, but local becomes absolute because it's an open interval with one critical point. And so we are going to differentiate again. (24x minus 64). The second derivative test says plug in the critical point, in this case 4/3, and evaluate it to see if it's positive or negative. So 24 times 4/3 minus 64. Now this cancels this one, gives us 8 times 4, 32 minus 64 is negative 32. Doesn't matter 32 or any other number. What matters is the sign. Negative means concave down. Looking like this, we have the maximum. So the maximum occurs when x is 4/3. When x is 4/3, what is this side? 8 minus 2x. And of course, class 8 is 24/3. And 2 times 4, 8/3. We get 16/3. So the dimensions being 4/3 by 16/3 by 16/3. What is the maximum volume? Multiply them through, you get 1024 over 27, or 37 and 25 over 27 cubic inches. Word problems always put the proper units, everybody. A stereo manufacturer determines that in order to sell X units of a new stereo, the price per unit in dollars must be P of X equals 1000 minus X, lowercase p of X. The manufacturer also determines that the total cost of producing X units is given by C of X equals 3000 plus 20X. Find the total revenue. And that's elementary algebra. Revenue by definition is the price times the number of units. So the number of units is X, the price is 1000 minus X. And therefore we get 1000X minus X squared. That would be the revenue function. Find the total profit function. Lowercase p represents the price, uppercase P represents the profit, and it's obviously defined as revenue minus cost. So we're going to subtract this one from this. And so I'm going to distribute the negative sign, minus 3000 minus 20x. Combine like terms, put it in descending order. I get minus x squared plus 980x minus 3000. All of these steps so far are purely algebraic. How many units must the company produce and sell in order to maximize profit? Let's do calculus. We're going to differentiate this. P prime becomes negative 2x plus 980. We set this equal to 0 and x becomes 490. So just move the negative 2x and divide by 2. Divide by 2. Is this going to maximize or minimize? We don't know yet. We go with the second derivative test. P double prime is negative 2. Negative means concave down, and that's a proof. This was the only calculus step, and we're done with calculus. Now the next step is asking what is the maximum profit? Algebraic step. What was the profit function in part B? We have that. Now we are going to replace the x here with what we found in the previous step. Minus 490 squared plus 980 times 490 minus 3000. You put this into a calculator and it results in $237,100. That is the maximum profit. What price per unit must be charged in order to make this maximum profit? Price function is P of X equals 1000 minus X. Replace the X with 490. And the answer is $510.